Let's get started with the normal distribution curve. So for that, I'll create a file which is called as the normal distribution dot, that will be first curve and second curve as per the two formulas which we have. So first thing we start with is import math. Import math is the functionality for the mathematics, and then we will import matplotlib for plotting up the curve. So this is matplotlib import pyplot as plt. After this, we'll create a function for the actual square root analysis, like as per the formula which we have. So that function will be considered as df normal underscore pdf with the values as x and mu equals 0. Mu is nothing but the mean, and sigma will be considered as parameter with 1. And after this, we'll create the square root for 2 pi as square root 2 pi equals mat dot square root. This is a function to get the square root of 2 into mat dot pi, and I'll return the value as return the one which we have inside the square root, that will be calculated with the normal PDF function. So return mat dot exponential with the value as minus of x minus mu, and this will be taken into consideration with 2 raised to 2 divided by 2. The complete value will be taken as divided by 2. So this complete value into 2 next will be the division with the sigma as sigma raised to 2. And this complete value will be divided by another value as square root of 2 pi into sigma. So we are evaluating like one part, like if you remember for the square root formula which you have, the one which you have within the square root. So let's have a look on the formula again. So we are calculating this section and into this part. So it is like we are doing it with the exponential formula, and this complete plotting like a square root of 2 into pi into sigma, that will be taken as one part. This will be calculated as other part, and then we will use a function of exponential in math using math in Python, and after that we will plot this particular graph which is represented over here. So let's get started with our code. Now after this, what I'll do, I'll create the xs function. So my xs function will be, or xs variable will be the one which will be plotted in the x-axis. So x divided by 10.0 for x in range of minus 50 and 50, that is the range given. And after that comes the plot parameter as plt.plot. So the value for plt.plot will be x's comma in array represented as normal PDF with the value as x and sigma equals 1. And after that we will use this value to the evaluation of the next section, that is for x in xs. Now next is we need to plot our labels with some formula. So for one value which is represented over here, that is dash, or we can say the hyphen, is nothing but the label. The label will be evaluated as label equals mu, or nothing but the mean value will be 0 and sigma value will be 1. So in the similar way we are going to do the evaluation with various set of labels. So this was for x equal to sigma as 1, considering for using the function of normal PDF where sigma will be 2, and in that scenario my label will be defined with 2 hyphens, and the value over here will be mu equals 0 and sigma equals 2. Then the next plot is when sigma corresponds to 0.5. Well, in that scenario, my value over here will be 0.5 and x in x's with the value as colon and the label name will be mu0 and sigma 0.5. In the similar way, I will have the evaluation for the next plot. After 0.5, the next plot which comes into picture is when mu is -1 and sigma is 1. Well, in that scenario, I will use hyphen dot. So I will take over here as sigma with a value represented like foreign x's with the normal PDF value with mu as -1. So here I'll mention as mu equals -1 for x in x's with the value represented with hyphen dot structure where mu is -1 and sigma is equal to 1. So we have plotted with our legends and we need to set this plotting with the legend value. So that will be given as plot.legend. And then we will use the scenario that is plt.title. And the title is various normal distribution curves. After that, we will say plt.show. So this part has been done successfully. So we have plotted our necessary normal distribution curve. So what we need to do is that we should call for our command prompt. So my command prompt over here is the get command prompt, which will help you to give the desired output. I'll redirect myself to desktop and Python scripts. Now I'll clear the command prompt. So now let's run the code as Python normal distribution 1.py. So this is the normal distribution curves which we have calculated. So with mu as 0, sigma as 1, it is represented with a straight line. With mu as 0, sigma as 2, it is given with the dotted line that is given with the legend color of orange. So automatically the colors has been set. So this is the basic example like we calculated using the normal distribution curve.